Okay. So this is assuming that you have gotten at least one plate that has between the 20 to 200 plaques. You can go up to 300 plaques on this. All right, that you can use to calculate your viral titer, right? So how many plaque forming units per mil? So how many little viral particles per mil? Okay, and so there are two formulas that you could potentially use. Okay, so there's the one that they provided at the phage program, which is your number of plaque forming units. All right, so the number that you counted, all right, divided by the number of microliters that you used to infect, right? So your volume you use for infection, okay, in microliters, right? So for most people, that's 10 microliters, but if you had a low titer, some people did like 100 microliters and stuff like that. So whatever volume you use, just make sure that that's what you are going to write down for that particular volume. And then, because we're going to have our final unit in mils, they're going to have you multiply by 10 to the 3 per mils, right? Sorry, microliters, my bad. Because we're going to cancel out that unit, right, per, right, mil. So that's our conversion factor for that, right? So we're going to cancel these guys out here, and that should leave you with your PFU per mil. And then, of course, we need your dilution factor. So we're going to multiply that by the dilution factor. So that's whatever plate dilution you used to count the number of plaques, okay? So that's how they're going to work this out in their formula. So in my example here, I had used fake number of 150 plaque forming units on a plate, and the plates that I used here as an example, I've got 3 plates, and we've got one that has a dilution of 10 to the minus 1, which represents our webbed plate, and the one that has that between 20 to 200 is the 10 to the minus 3 dilution. So it would be the 10 to the minus 3 dilution that you would use. Can you pause it? What was it? Oh, what do you need? Remember where I left off, whatever. All right, so I came up with a pretend number. So I said, let's say there was 150 plaque forming units. So I said 150 for my number, and I assumed that they used the 10 microliters for their volume, so that would be our 150 over the 10 microliters. And then we're going to have our conversion factor of 10 to the 3 microliters per mil. And then the dilution factor used was the 10 to the minus 3. Okay? Yeah. So this is how we have the formula, but if you prefer to do things in scientific notations, then we would have to convert these numbers into scientific notation so that you could calculate this without having a really fancy calculator in case you didn't have one, right? Most people have phones, and those have some limitations. So if we do this, we would have to convert this into the scientific notation, so meaning we have to move our decimal point over. So 1, 2, so this becomes 1.5 times 10 to the 2 PFU per mil, right, over our 10 microliters. All right, and so that would, then if you divide 1.5 times, so divided by the 10, then that's going to give you what? 0.15, okay? So that's going to be, I'm going to move this way now with this. We're going to have 0.15 times 10. I'm just going to leave this as the 10 to the 2 just for now. PFU. Per microliter, and then we're going to multiply that by the 10 to the 3, which is going to be our conversion. So we're going to get rid of those microliters over 1 mil. And so when you do that, we're still going to have our 0.15, because it's basically multiplying against 1. So we'll still have 0.15 times 10, but then when you multiply, you always add the exponents, right? So that should be to the 5, and so we've got PFU per mil on this. But now we have to take into account our dilution factor that we had. So we have to multiply again, times 10 to the 3 for our dilution factor. So then we've got our first number here doesn't change, 0.15, but then we got to add our exponents again. So that's going to be to the 8th, okay?
Explain why it's 10 to the 3 and not 10 to the minus 3, because you have.
Oh, you're right, right. Oh, ha ha ha.
Yeah.
Yep. I forgot with this formula, you don't use the negative. You just use the positive value with this formula. All right, so I forgot about that.
Right, you diluted it 1,000 times.
Right, you diluted it 1,000 times, so that's why they're just saying, okay,
Multiplying by
we're going to
1,000.
put it as an exponent, right, 10 to the 3. And so instead of saying negative 3, you would say 10 to the 3, right? So with this formula, that's how it would work, okay? So that's why we're going to multiply that by 10 to the 3, so that gives us 10 to the 8th. But again, this is not at the proper scientific notation. We would have to move this back over here. All right, 10 to the, we're going to go up or down?
Down. 7.
All right, PFU per mil, okay? I always recommend students do this, and if you have a fancy calculator, check it on the fancy calculator. And the more you do this, right, the easier this is going to get, and then you won't have to rely on the fancy calculator, and you'll actually trust what you're doing, okay? So this is the first formula, all right? So I'm going to leave this number here and erase the rest,
This is basically the one we have.
so that we can talk about the other formula that is used, and it should match this number here.
Because I've done both, but I feel like this gets a little.
All right. So the other formula that you can do is, again, number of plaque forming units. But we're going to divide it by the volume, and the volume is already going to be converted into mils. And then multiply by your dilution factor, okay? And we should come up with the same answer. So if we use the same numbers, we had 150 plaque forming units, and then our volume that was 10 microliters, right? We're going to convert our 10 microliters into the milliliters, right? So if we do that, it's either 10 times 10 to the 3, but that's not correct scientific notation, so we got to move the decimal point over. .0 times 10 to the 2 mil, and then we're going to multiply that by the dilution factor, and in this formula,
That needs to be a -2.
thank you,
You're welcome.
-2, all right, -2, and then we're going to go ahead and do the dilution factor, which in this situation was 10 to the -3. And we do not change that, we leave it as the 10 to the -3 in this formula, okay? So we don't have to change that or worry about having to change that, okay? Once again, we can turn this into the scientific notation. 1.5 times 10 to the 2 PFU over 1.0 times 10 to the minus 2 mil times the dilution factor of minus 3. Okay, so we always start here at the bottom to simplify what's going on here at the bottom. So we have 1, which is basically multiplied by 1, so we'll keep that the same as 1 times 10, and then we're going to add our exponents, so minus 2 plus a minus 3 is going to give us minus 5 mils for our volume, okay? And now we can do the division of 1.5 divided, times 10 to the 2 divided by 1 times 10 to the minus 5, so I'm going to make it nice and clean over here. 10 to the 2 PFU over 1 times 10 to the minus 5 mil. Now when you do division of the exponents, you have to subtract instead of adding, okay? So here 1.5 divided by 1 is going to still be 1.5, and then we've got times 10, and we're going to subtract our numbers. So think of it this way, right? 2 minus a negative 5.
I just make a plus when I do
I
that.
think that's the point I'm getting
Yeah.
at. Subtracting a negative is essentially adding, okay? So this is the same. Just take these guys, put them together, right? 2 plus 5.
Yeah, what I mean is I usually draw a plus through it.
Yeah, I
That's how I do it, but yeah.
I'm just explaining where this is coming from, okay? All right, so 2 plus 5, so that's going to give us 7 PFU per mil, which is what we got with the other formula, okay? So either way should give you the correct answer. And again, just double check with your fancy calculator at first if you're uncertain about your math, okay? All right, so now we know how many viral particles are in your lysate that you collected, okay? In the end, what we want to do is create the webbed plates, right? Meaning that the majority of the bacteria is going to be destroyed. You'll have these wisps of bacteria present, so it's mainly virus on the plate, okay? So we have to figure out how many plaques is it going to take to create this webbed plate, okay? So in my example, I have the example of the webbed plating on here. And then we've got the plate that we used to count. And so what you can do is go, okay, well, the webbed plate is a 10 to the minus 1 dilution, which is 100 times less dilute than the plate I used to count, which was the 10 to the minus 3. So in theory, if I had 150 plaques at 10 to the minus 3, that means that at the 10 to the minus 2, I should have 10 times more. And then at the 10 to the minus 3, I'm sorry, 10 to the minus 1, I should have another 10 times more. So we're looking at 15,000 plaques needed to create a webbed plate, right? And this is an estimation, okay? This is an estimation. Other ways of doing this involves measuring the size of your plaque and measuring the size of the plate and trying to figure out exactly. That's complicated. I think the estimation just works better, okay? So we're going to estimate, and we've estimated that we need 15,000 plaques, okay? So we've got our titer, and we've got our estimation. All right, of the number of plaques that we need. So now we can figure out what volume is needed, okay? What volume is needed in order to create that webbed plate, okay? So what we can do is take the number of plaque forming units that are needed and divide it by your calculated viral titer. So in this situation here, we need 15,000 plaque forming units, and we're going to divide that by our calculated 1.5 times 10 to the 7th PFU per mil. And you'll see that the plaque forming units will cancel out, and we're going to be left with the mils. All right, so double check here what I got. Okay. So again, we can simplify this. 1.5 times 10 to the 4th PFU, and then our titer again, 0.5 times 10 to the 7th PFU per mil. We're dividing, so 1.5 divided by 1.5 is going to give us 1, and then our exponents we are going to subtract. So that's going to give us 10 to the minus 3 mils. Okay? But we have to do everything in microliters. Okay? So we're going to convert this from the mils to the microliters. So we have to use our conversion again. 1 times 10 minus 3 mils, all right, and basically 1 mil, right, 10 to the 3 microliters in 1 mil. We can cancel out our mil units here. So again, we're going to go ahead and add these up. Minus 3 plus 3, 1 microliter. We're looking at 1 microliter of the lysate needed to create a webbed plate. Okay, that's a really low volume. I don't like that, especially if we're trying to use P20s and stuff to do our pipetting.
We have P2s, but we'll use those later. We're not using
Yeah,
it.
that's it. No, we're going to pretend the P2 doesn't exist, right? So we don't want to do 1 microliter. We want a larger volume to play with, okay? So to solve this problem here, raise the board over here. We can go ahead and dilute, make a dilution of your lysate, so we have a greater volume that we're using. So go ahead and make a serial dilution. It could be a 10 to the minus 1 dilution. Instead of 1 microliter, you're going to be using 10 times more. So that's going to be 10 microliters. A much easier volume to play with. Okay? So for this calculation here, since they had a fairly high titer there, we're going to use a dilution so that we're going to use the volume 10 microliters instead of 1 microliter. Okay? So to make a web plate, we need a 10 to the minus 1 dilution, and we're going to use 10 microliters of that to infect the cells. Okay? But again, we're playing with estimates here. So it's always a good idea to bracket, meaning that we're going to have a volume higher and a volume lower than our estimated volume here. And how you bracket depends on the size of your plaques. Okay? So in your instructions here, I give you examples of how you would bracket if you have large plaques, how you would bracket if it's medium size, or if it's really small. Okay? So if we have the assumption that this is medium-sized plaques, according to our rules here, if it's a medium-sized plaque, then you would use 5 times less volume and 5 times more volume. Okay? So in this situation here, if I draw my little plates. We're gonna have 3 plates in the end. Our middle plate is going to have that 10 to the minus 1 dilution with 10 microliters in it. And if we're using that same dilution, that would mean that our 5 times less, if we use 10 to the minus 1, would end up being what? Two microliters. Is that a good volume to play with?
No.
So how can we solve that problem?
Add a little bit more. I don't know.
More?
We still want to do 5 times less. How could we solve
Make
that?
another dilution.
Make another dilution.
Yeah.
All right, so in this situation, instead of using a 10 to the minus 1 dilution, right, we're going to make that a 10 to the minus 2 dilution, so that we can use 10 times more, and that becomes 20 microliters. I lied. 5 times less. Yeah, no, that's fine. Yeah, because we're doing 5 times less volume on this plate.
But it's a 10, yeah.
All right, 5 times less. So if we were to use the 10 to the minus 1 dilution, that means we're playing with 2 microliters, and we don't want to play with 2 microliters. So we're going to have a dilution of 10 to the minus 2, which is 10 times more dilute. So we use 10 times that volume, which should be 20 microliters. Okay? All right. Now on this one here, so I'm going to say here 5 times less. Here we're going to go 5 times more. Right? So we need 10, so 5 times more of this 10 to the minus 1 dilution. So that's going to put us at 50 microliters of the 10 to the minus 1 dilution, which is still doable. We can work with that.
Okay.
Okay, so now you have your estimated volumes that you're going to use to bracket your plates. So you'll need to make a zero dilution that goes up to the 10 to the minus 2, and then you're going to infect your cells. So you'll infect your cells, you'll have 1 tube that's using the 10 to the minus 2, you'll infect with 20 microliters, 1 tube that's you're going to use the 10 to the minus 1 and infect with 10 microliters, and a 3rd tube where you'll use the 10 to the minus 1 and infect with 50 microliters. Okay? And then you do your usual plaque assay, leave your plates there, and hopefully, right, you'll have a nice wet plate here. Hopefully this will be still webbed and not totally blown out, right? And this one might also still be a webbed plate, right? But the point is that we'll have a lot of virus either way, and hopefully you'll be able to collect those lysates and do your titers again. And our ultimate goal is to have a high titer lysate, so we call it HTL, high titer lysate of about 5 times 10 to the 9 plaque forming units per mil. So we're basically going to keep doing this until we have that.
And 9 mils of that?
About, yeah.
Yeah.
9 mils, roughly. Okay? Because we're going to use this to isolate DNA from for our restriction digest, and also send 1 sample off for sequencing. And then we're going to send stuff to CU for the electron microscopy imaging. They'll take as low as 10 to the 8th, but they prefer the 10 to the 9th, and since they charge by the hour, it's better to have the higher titer, so it's easier for them to find the virus, and it won't cost us as much. But that's basically the math
Okay.
that you would do.
I think this is what I wanted.
That was a
the
good
volume
sure.
one.
That came back. but
Yeah,
it
the
took a
volume
second.
one.
I stop
was
it now.
the
Yes, go
one
ahead.
that I think I had